a lot of you asked for this. Yeah, you will have the recording of the session, Gaurav, on our YouTube channel, maybe by tomorrow morning. So you can always have a look in that. Okay, fair enough. So when you talk of data science is all about predictive analytics, right? And in predictive analytics, what we are trying to do, we are trying to take a set of data and trying to solve a business problem, right? Primarily, we take a business problem, figure out what data is important to that business problem, and once we have found the data, we try and do the analysis of that data. We try and use a lot of statistical. So to analyze that data, we use a lot of statistics, right? I'm sure you had heard of the term machine learning algorithms. So that is nothing but, again, advanced statistics. So this to analyze a set of data, to be able to explore a set of data, you need a lot of analysis to be done on that data. Okay. uh, Fair enough. So how exactly it happens? So to be able to work with data, to apply predictive analytics, to be able to get to that level, what you really do is you take a set of data. Okay. So you take a set of data and you apply statistical algorithms on data to get some kind of a pattern, to get some kind of an insight. Okay. Once you have the insight or the pattern in data, you would be able to, using those patterns, using those insights, you'll be able to make sense of the business problem. You'll be able to use and you'll be able to use those analysis or insights that you've got from the data to improve your business decision making, right? You'll be able to improve the business decision making. So statistics does play a very, very important role in data science. Again, I'm focusing on that because a lot of you have been in that notion that, I'm from an IT industry, and if I understand R, or if I learn R for data science, probably I become a good data scientist. So that is a very big misconception lot of people have today. So just want to clear the air there, that it's not only about statistics. Data science is an amalgamation of multiple things. Okay, so it involves a lot of domain knowledge, it involves your problem solving ability, it involves a lot of statistical understanding, right? Again, when you get into data science, it's all about your logical ability, your quantitative ability. And once you are good with quantitative ability and logical ability, you start learning, and you can go ahead and learn statistics. And then to be able to apply that statistics on data, you need some of the other tools. And therein comes your tools like R or Python or SAS, or even Excel, right? Any of the tool can be used. All right. So primarily it's about a lot of statistics and ML. Machine learning, again, is advanced statistics. So machine learning plays a very, very, very key role in data science. Okay. I see a lot of you have joined a little later. I've pinged you a form. Please fill in the form. I would need to give you the uh, access for this session. So, or access to our online lab. So if you could fill the form, I'll be able to give you access to that, right? It'll really be helpful if you could do that. All right. Uh, Coming back here now, this in a nutshell is data science, right? Again, and when I'm talking of data science, it's primarily I'm talking about predictive analytics, which is where we have focused on, right? We're not really talking a lot about the reporting of data or cleansing and all of that, right? So data science, it would involve all of that, but we're primarily talking of predictive analytics, which is the most important aspect of data science. Okay. Then in data science, as I said, you can do a lot of analysis of data. I'm not talking about any other things today. What are the tools, why you use that, and what is the difference between various kinds of technologies that you have, so on and so forth. I'll still open the floor for questions towards the end. I'll probably take your feedbacks as well. But before that, let's directly dive into the case study and start solving the case. Okay, so please, those who have not filled the form, quickly do that. We'll take a very simple case study, which is on credit risk modeling. I'm sure many of you are aware of this. Many of you understand what credit risk modeling is all about, and many of you might have actually done the credit risk analysis earlier as well, right? So in credit risk modeling, what is the basic aim of, or what is the basic problem that we are trying to address? The most important problem that we're trying to address there is that you, as a banker, or anybody, any bank, wants to decide whether the bank should allow or give the loans to certain individuals or not, right? It could be various things, right? So within a bank, there could be various kinds of data science problems which can come up, right? So for example, suppose I just want to start with a marketing campaign. Okay, so for that marketing campaign, I decide that I can, okay, I can, and the marketing campaign is primarily about loans. Okay, now I as a banker has to decide how do I go about doing that marketing campaign. Again, people who are into marketing can again understand this a little more. So I as a banker want to decide, or I as the marketing team in a bank want to go about and decide how exactly I would do the marketing for my loan, right? I'm giving loans at a certain rate, and I have a lot of money sitting idle with me, and I decide, let me try and go out and put this money to some use. But that money would be helpful to me only when, if I am able to put it to loan, I am able to give out the loans to individuals who are looking for it. uh, that's one thing. So identifying people who are looking for loan, but then more important is to identify people who would actually take the money and not really run away with my money, right? They will pay me back, because other than I end up not really earning anything, I end up losing my money. Correct. And in India, you obviously would be seeing so much, you know uh, we have so many defaults which are happening, and there's so much talk about it these days. So when you talk of defaults, as banks, you really don't want people to default on your loans, because as default happens, you really are ending up losing a lot of money. Okay, so second step is the same question. So marketing campaign, guy wants to decide who I want to really lend it out to. So I can decide, okay, it can be all my existing customers. I can take the data of those existing customers, and then decide which of those people might be likely to take a loan, again based on those people who have taken the loan from me. So I can do some kind of analysis there and do that. But in this problem set, we are not really addressing that. We are trying to address another problem where we are trying to say, if I have a set of data, how do I really do the analysis of data? And when I am analyzing this data, I want to figure out what kind of people uh, would take my loan and really give it back, right? They would let it come back to me. They would not really take the money and run away. Okay, so I want to figure out good good uh, good people to actually loan give out the loans to. Now it's very difficult for anybody to know before you give out the loan uh, whether somebody is going to pay you back, or he's actually taking your, he'll be taking your money and running away with that money, right? So you cannot know that say 5 years, 10 years, 15 years, 20 years, you know prior to that happening, right? Because generally the loan periods is anywhere between 0 to or 1 to 20 years, or it could be more as well. So as a banker, as an individual, when you're trying to put out the loans there, it's very difficult. So therein comes the analytics can come into picture. It can help you take a decision not just based on your gut feeling. It can really help you take a decision uh, based on the data, right? Okay, so I have a question which says, are we using logistic regression here? So primarily not as of now today, Sivashish. This session will be primarily be about doing univariate and bivariate analysis. We have another session on machine learning, which is happening Tuesday. So you people can come in again, do an analysis, or of we'll take up again any case study and really try and do a lot of analysis on that data. So that's happening coming Tuesday. So all of you can certainly join that session as well. Okay, coming back here. So I was saying I need to figure out which all people would really default, and so whom should I give the loan and whom I should not give the loan. Let's quickly take this data, and what I would want you people to do is, you can take this data. One sec, I think I need to go back and pull this up here. Okay, I've got this data here. I'm pinging everyone the link for this data now. Okay, you can take this data. Everybody can download this data. This is a simple CSV file. I've really not tried to make this file very complex. It's a very small set of data that we're taking, and we'll be analyzing that small set of data, because the idea is to teach you basic stats and tell you how exactly you go about doing analysis in statistics. Okay. uh, all right, are we good, everyone? Once you've got the data, we'll try and analyze that data in depth. Okay. Um, One sec here. Okay, all of you have filled the form. Anybody who has not really filled the form, please fill it once. Please fill it now. Okay, fair enough. So let me quickly give you the um, access, how exactly you'll be accessing that. Sorry, uh, that not really was intended for you. Uh, so Himanshu, if you could ping the link for the lab on the chat window to everyone, everybody uh, will be able to do
Sure,
that.
Kushal. Just a second.
Yeah.
Yeah. So that's the link. Oh, sorry. I just pinged it to everyone.
So this is a link to our lab. You can log into the lab, and how we'll be giving you the ID and password for the lab here.
Yes, I believe all of you can see my screen now. So these are your login and password along with your email addresses. So make sure that you are using your own only.
So a lot of people, I don't know, there are 23, 24 people. Everybody has filled the form, because I see that 34, I mean, about 23, 24 people in the session. But some of you seems like have not filled the form. Those who have not filled the form can again fill the form on the link that I pinged you some time back.
I believe all of you can log into the lab.
Anybody who's having issues logging onto the lab?
So I'll just show a demonstration in case it's not working. See this. So there's the login. So the username and password you have to put in over here, and then simply put a sign in. Okay, just a second. Who's this? Just a second, Kashyap. So it might take around 10-15 seconds to start.
Yes, everybody has signed into the lab.
Okay, I think you have two more participants. Just a second. I'll just put them also. Okay. So Mr. Kashyap, you can use guest 19 and guest 19. And Ramanand, you can use guest. Sorry, this is. Yes, you can simply use guest 20. Guest 20. Ashish, yes, is yours. Yours is guest 16, guest 16.
All right, everybody is good. Okay, I'm taking away the screen. Okay, everybody has got the access to the lab.
Yeah, I think so, Kushal. All are good. You can
Okay.
take forward now.
Okay, great. So I'm taking away the screen here. Okay, and this is how my lab looks like. Himanshu, I think you logged into the lab as well. Can you log out
Yeah,
of that?
you can connect now.
Okay, thank you.
I'll just close it. Yeah, yes, you can do that.
Okay.
Just log out once and then log in again.
All right. Okay. Fair enough. So when you're talking about data, we are seeing this data, right? This is the data that you're working on. Okay. So when you're trying to do analysis of a data, right? First of all, you need to understand various things in the data, right? If you look at this data, you have about 1500, approximately 1500 observations, which is very, very less. Ideally, I have a data set which contains about 5 lakh, 5 lakh rows, but I've taken only 1500 for the simplicity of this class. I really haven't taken all of that here. Okay. So just because I really did not wanted to make it very complex. Many of you are pretty new to this, so I wanted to keep it a little simple. Okay. Am I just still having issues with that? No problems. I'll use the other one. Uh, okay, fair enough. Okay, now this is my data, right? Now in this, what I really want to understand, what kind of analysis I want to do. I said I want to do the univariate analysis, right? Or basically when you do the analysis of data, how exactly you do the analysis, there are various steps to analyzing a set of data. Okay, I'll quickly tell you what are those steps, right? And once you have understood those steps, I mean that will be followed mostly with most of your business problems. Okay, so when you have to analyze the data, first and the foremost job is to understand the business problem. Okay, here in this case, you have got a lot of again, I've removed a lot of variables as well over here. I've taken only certain few variables. So if you look at this data, we have about 1, 2, 3, okay, about 12 variables. Okay, is what I have now. First thing, when you're trying to understand, the first and the foremost job is to understand the business problem. Once you have understood the business problem, you have collected the data pertaining to the business problem. Now the job starts. Okay, first and the foremost thing is you need to understand the data. Okay, what kind of data do you have? Okay, and when you say you want to understand the data, there are various steps even to that. Okay, for example, uh, in this case you want to understand this variable, and in the understanding of the variable would include, uh, first thing I would want to know, okay, what is it that I'm trying to predict here? Is there anything that I want to predict? Do I have a variable which is, which is a dependent variable, and there's a variable which is an independent variable? So I would first try and understand what is my dependent variable and what is the independent variable. Okay, so if anybody who understands the difference between dependent and independent variable. Okay, so when you talk of dependent, so here in this case, or you can also call them as target variable and predicted variable, or predictor variable, right? Predicted and predictor variable. All right. So if you're trying to use, say, the predictor variable, uh, then in that case, what you do, you would want to understand what is it that we are trying to predict. We're trying to predict the loan status here. I mean, in this case, this loan status has two values, either charged off or fully paid, right? So these are two different values that I have this in this, and this variable tells me whether somebody has taken the money and actually paid me back, or he has just taken the money and run away with it. Okay, so I know this, that okay, with this data I have a clear understanding that this is the data that I'm trying to predict. With other variables I'm trying to predict uh, okay, with other all right, couple of people pinging here, no problems. Yeah, so with this, now this is my variable that I'm to predict, right? I'm trying to predict whether somebody will take the money and run away, or whether he'll give me the money back. So whether he'll pay me back or he'll run away, that I'm trying to predict based on the other variables, right? So here this variable could be current loan amount, it is term, short-term loan or long-term loan, what is the credit score of that individual, how many years is he present in the current job, home ownership, does he own a home, or is he living in a rented space, right? Or is he having a mortgage to the home, so on and so forth. Annual income is there, years of credit history which is present for that individual, number of credit problems that he has had, current credit balance that he has, and so on and so forth. You have a lot of variables here, right? Again, I've taken very few, about out of 12 variables, this one is the variable that is the uh, predicted variable or the target variable. Now, apart other than this, all the other variables, I'll be using them to understand whether I can predict this value on the basis of the other variables or not. Okay, clear? So first and the foremost job is to identify the predictor or the target variable and the predictor variables. First job is to do that. Okay, we have been able to do that. So for us, loan status is the the target variable, and the other variables are, okay, hold on. Uh, are you able to hear me well? Are you able to hear me well? Yes, no? Can you just ping me?
Yes, we can hear.
Okay, thank you. Anubhav, that network at your end, so please, uh, yeah, thank you so much. Guys, you can be on. Okay, generally in my sessions, I try and keep everybody unmuted, and provided there's not a lot of disturbance. So that's your problem, Anubhav. It's certainly network at your end because others are good. If that was the case, everybody else would also have faced the same issue. Fair enough. Coming back here. So now this loan status is the variable that I'm trying to predict. All the other variables are the predictor variables, or the variables which will help me predict this value. Okay, that's the first thing you need to understand. Once you have identified the predictor and the predicted variables, then you can do the univariate analysis. Now, what do you mean by univariate analysis? Uni means one, variate means variable. So you're trying to understand each variable. You're trying to do the analysis of each variable. So current loan amount, what is the, how that data is varying, what kind of analysis you can do there, what I mean for the term, for credit score, for years in, I mean you'll try and explore each variable. Okay, now when you explore each variable, when you do univariate analysis on that variable, again there'll be various steps that you need to do. We'll come to that, right? Once you've done the univariate analysis of this data, right, once the univariate analysis of this data is complete, then you try and go ahead and do the bivariate analysis. Okay, so there you'll try and understand or find the relationship between two variables. In this case, I'll try and understand maybe whether my loan status has any has a relationship between current loan amount or not. Is it related? What kind of relation does it have? Again, the significance of those two variables, right? So there are, it could be one categorical data, one continuous data. Again, I'll talk of categorical, continuous. But when you do bivariate analysis, you'll be able to take two variable and find the relationship between those two variables and understand whether the relationship is significant or not, right? All those things we'll try and understand today later in the session. Okay, fair enough. Now, once you've done that, then you try and, okay, once you've done the bivariate analysis, or even before bivariate analysis, you try and clean the data. You try and understand, do you have missing values in your data? Do you have outliers in your data? And then you try and treat them, right? You try and do some kind of treatment to those things so that your data becomes good enough for doing the analysis. Okay, you might do feature engineering, you might do transformation of the variables. There are various steps which are needed to do that. And then towards the end, you'll try and maybe say find the, when you do bivariate analysis, you can find, you know, the relationship between two correlation. You can check the covariance between variables. You can check the whether two variables are related to each other in any way or not, right? So all these analysis will be done over a period of time. Again, you can draw a lot of plots, you can do the analysis using that as well. And once you've done with those analysis, you will be able to um, get to some kind of a conclusion, right? You'll try and understand what kind of impact does it have on your data. All right. First thing is we'll try and understand the variable. So first we have done is we have figured out what is the predictor variable and what is the target variable. Okay, till that point we are good, right? Okay, fair enough. Now let's try and uh, do the other things, and that will be uh, now the next thing I want to understand, what are the data types that are present in this data. Okay, what are the different data types present in this data? Okay, so if you look at this data, this is a loan ID, seems a very unique number for every individual, for every row. So this seems like a, if I have to put it in this in my in R or Python or any of the tool, it'll tell me, okay, this seems like a string variable, right? Again, this is my customer ID, which is again unique to a customer. This again should be my string data, and you will have a lot of values to this, which again should be unique across the board. Then you have charged off. This is another. This is again a string value, right? Here this is a or string or character value. This is again your numeric data, string data, numeric, again string data, numeric data, numeric data, numeric data, numeric data, right? A lot of that you have. Now once you understand, okay, these are the data types, and make sure that it's not that this data is numeric and system is taking it as factor or categorical data and other things, or system is no it's a numeric data and system is actually taking it as factors, or if it is a factor, system is taking it as numeric. They can be mismatched there, system can understand it differently, so you need to correct that, okay, before you proceed with the analysis. Now once that is done, once you have understood the predictor variable, once you have done the figure out the data types, then you need to understand how many of these are categorical data and how many of them are continuous data. Okay, everybody understands or not sure how many of you understand about categorical and continuous data, so I'll quickly explain you that as well. Where was yeah, just give me one sec. Yep. All right, so when you talk of categorical data and continuous data, anybody who has an idea of what is categorical and what is continuous?
Hello.
Yeah, go on.
Yeah, I think continuous data would be like time series data, and categorical data is discrete.
Okay, categorical data is discrete data, and continuous
data is like time series, like like the opening and closing market stocks prices.
Okay.
And we have
various examples. Yeah, simple. Anything which is numeric generally, where you can perform numerical analysis on the data, that's continuous, right? So which is changing with respect to time, which might be constant around with a time, does not really matter. But continuous means that can take any value between minus infinity or plus infinity. When I say in general, it can take any value in the numeric range, right? Not necessarily always between minus infinity and plus infinity. Okay, my voice was echoing from somebody's side. I've muted you. So it'll generally take numeric data, right? Is what? Okay, Kuldeep, you can keep yourself muted. Please don't unmute yourself. My voice is echoing at your end. Coming back here. So I was trying to tell you that this is the numeric data or time series data, as rightly pointed out, which is a continuous value, right? Which can take any continuous variable. When you take categorical data, this is primarily a discrete data, or discrete or data which can take only certain fixed values. Continuous data can generally take any value. Categorical data can take only certain fixed values. For example, your gender. For example, your blood group, your country of origin. Again, these are all categorical data which can take only certain fixed values. You cannot have, your blood group like just about any value. It will be certain fixed values. Continuous, as I said, it's a numeric data is what we have. Okay, let's try and understand out of these data points which of them are categorical, which are continuous. Okay, loan ID. Do you think this is categorical or continuous? Loan ID will be. It's a categorical data, right? Because each loan ID is separate. And if you have to understand whether it is categorical or continuous, try and think if you perform some numerical operation on this data, does it really make sense? If it makes sense, it can be numeric. If it really does not make sense to perform numeric operation on data, that generally is categorical in nature. Okay, that is also one way in which you can understand that. Customer ID, this will again be categorical data which will have a lot of categories. Okay. Loan status, this will be again categorical. Yes, everyone. So you need to be a little participative so that we all of us can learn. Again, some of the things are pretty basic, but again, if you participate, session could be more interesting. So this is loan status is again categorical. It can take only couple of values, charged off or fully paid. Then you have current loan amount.
Continuous data.
This is a continuous data, correct?
Yeah.
All right, great. Short term, long term, again, this is categorical data. Credit score. Credit score is a continuous data. Years in current job, what will this be?
It's continuous.
Okay, this is again a categorical data.
Categorical.
In this case, I have this as categorical data. I could have it as continuous also, but as of now, I have defined certain categories, and that is why this is categorical data. Home ownership again will be categorical data. Home ownership, right? You have only few values here. Annual income will be
Continuous.
this is continuous. Great. Okay. And years of credit history. Now this is continuous, right? Again, I have values which is ranging anywhere. So I've not really put in certain category on which the data has to be. All right. Number of credit problems that somebody has. Okay, I can treat it as continuous also, as categorical also. I can decide how to do that. Okay, a lot of disturbance from somebody's side. Please you mute yourself, whosoever it is. Thank you, Sanjeev. All right, and then you have current credit balance. This will again be
Continuous.
this is a continuous data, right? So we have identified some categorical and continuous data. Why we have identified this? Because when we are trying to analyze a categorical data, the analysis is very different vis-a-vis when you're trying to analyze a categorical data, right? The analysis would entirely change. It would make more sense to do the analysis in a certain way for these types of variables. All right. Okay. So in this case, let me first I've given you this data, right? Let's import this data into R, right? And we'll work on that data. Okay, not sure why this is
an old version of our studio.
Okay. All right, great. So everybody understands R Studio, or you want me to give you a very quick overview of this?
Please give an overview. Yeah.
Okay, fair enough. Let me do that. Okay, so you might see it like this, or you might have all the 4 windows in there. If you don't have 4th window, just go to File, New File, and R Script. This is how your R Studio looks like. Okay, so R, if you talk of R as a tool is okay. Sorry, I need to mute everyone. My voice is echoing again. Yeah, thank you. So now when you work with R Studio, then if you see here, you see the 4 windows here, right? Correct. Now R as a tool is a console-based programming language, and RStudio is generally an IDE. Okay, I'll quickly show that up to you people. This is here, right? So IDE is RStudio, which I'm trying to use here, and IDE is nothing but a GUI based thing which will help me work with the R easier, right? Here, this, if you look at the first window, this is my script window. This is where I'll be writing my script. I'll writing my code here, right? Whatever code I have to write, I write here, and I'll execute the code at this point, right? Once I execute the code.
Hello.
Yeah, hold on. Who's that?
Yeah, this is Prakash Kumar. Just now we joined in the.
Okay, Prakash, you've joined in the middle of the session, so try and follow whatever is happening, and you can try and do whatever is. I mean, I'll give you the links for the session for the data that we're working on. So just hold on to that. I mean, it's not really the best time to join in the session. Okay, coming back here. So okay, I lost my thought again. This is really bad. Coming back here, so I said now this is where you're writing the code. Okay, and once you've written the code, you need to execute the code. So how do you exactly execute the code? You say control plus enter. That is one way to execute the code, or you can put the click on the run command. Either ways, you will be able to execute the command, and the code will be executed here in the console. And once the code is executed, you will get an output which will again be shown here itself. Okay, if you're trying to create a variable, that variable gets created in the, or that object gets created in the global environment, and you should be able to see it here. Okay, plus there are help plots, and okay, plot is important. We'll be seeing the plots. So plots is where we'll be seeing all the plots that we create. Okay, so we'll be doing that in a while. Okay, and then we'll be able to understand that much better. Great. So primarily you understand that you'll be writing the code here using control plus enter. You'll be executing that here. Once you've executed, make sure that object is created here. If you're trying to create an object, that object should be present here. Once the object is present, you can be sure that the command has been executed, and you can start with the analysis, right? You can start understanding what it is all about. Okay, and here in this one, you'll see the plot. There are other things, packages, help, and other things. Again, I don't think we have enough time to explore all of that now. All right, fair enough. Again, R will allow you multiple data types, multiple data structures. Again, I'll give you very quick, brief of whatever is required in the session only, right? Once I import the data, whatever we need, I'll give you the brief of that. Fair enough. Okay. All right. Now let's get started here. Okay. So first thing that I want to do is I want to import this file into R. Okay, all those who have got access to this RStudio, either you have it in your system or you're using the cloud base that I've given the access to you for, you can use either of that and you can work with this, right? So first of all, you need to import the data into R, right? That is the first thing. Now to be able to import the data into R, see, there is something called default directory, right? When you download a file from say internet, it gets in and saved into a certain location, right? Which is a default location. Similarly, when you're trying to import a file or export some data, R will go and sit in some or search in some default directory. Okay, and again you can set that directory. You can decide to have select where that directory would be. Up to you, right? Where you want to put that directory. The file should be present there, and okay, I'll share the link to the data once again. Before that, I'll just give you how you can set your working directory. So that's called working directory, with which R can connect to the other files. So you go to session, you can say set working directory, choose a certain directory. Right, so here it is present over here. Okay, so you'll have to do it on this one. Again, I'm not sure you have files here. So rather than doing that, what you would do, you can just take this link to the file which I had given you, and you can use that link to directly do the analysis, directly import it. So through the URL, URL also you can easily import the data, right? So where was the link? I'd given you the link a while back. Yes, seems like this is what it is. Yeah. So this is my data. Okay, I'm giving you the link to this data once again. Okay, what you need to do, since this is a CSV file, again I'll do a simple command read.csv and I'll pass this. So again, understand R is pretty simple to work with. It's primarily um, a function based language where you can easily call a lot of functions. Again, you don't need to be a very good coder, you don't need to be a smart coder to, I mean, you need to be smart, you don't have to be a laborious coder, you don't need to know everything in depth beforehand to get into R is pretty easy to understand. It's primarily a statistical tool, and when you start with R, it's just that you will be using functions which again somebody has built. You're not really building new functions every day. Very rarely you will have to do that. Most of the functions, most of the tasks can easily be done by using the existing functions, and that is where you have packages which are the libraries which will add those functionalities to R. Okay, so for example, I want to import this file into R, and what I really want to do is I want to save this in, say, I decided to put it in some variable, say credit data. Okay, now credit data is the variable that I want to understand, and here this read.csv is the command that I'm using. This is the function I'm calling, and this is the argument to that function. This is the link that I'm passing to this function. Once I run this command, you see this execution is happening, right? How do I know? There was this red button which was popping up here. Okay, and if you have executed, just see that there's red button which will come up here, which will tell you that okay, currently R is executing something. Okay, so you need to wait till that execution happens. If it really takes a lot of time, make sure that you stop the execution and try and do that again.
So hello Kushag, if I say file.choose, it will do the same thing as read.csv.
Sorry,
File.choose bracket open. If I do write that instead of read.csv, so that automatically becomes the file from the link which where the file is.
Yeah, so maybe I really don't know. I have not used file.choose function.
Okay.
Okay, I have not used file.choose function, so probably I'll not be able to talk about that.
Shagru, one more question I have.
Yeah, just ping.
If I have downloaded the
Yeah, can you ping me on the chat window? It'll be better.
Yeah, I have already written the question. I guess you haven't read it.
Okay, no problem.
I have it, the CSV file on my desktop. How to upload that here?
If you have your CS, so in the through the online lab, you have to put that file on the lab, right? It's a cloud-based thing, so the cloud will not be able to access to your desktop. In case you're using your RStudio on your desktop, then you can easily work with that. And in that case, you can, as I said, you can go to session, set your working directory as this directory, and you can simply use same thing, read.csv function.
Or instead, you can also get wd function, which will directly give the directory where the file is saved.
No, so getwd will not give you the directory where the file is saved. Getwd will give you the current working directory, right? So if you do
current working directory.
Correct. So that will only give you the current working directory. You can get the working directory and set the working directory. I was trying to tell you how do you set it. Okay. So when you run this command, a command will run setwd, which will do the set the working directory where the file is. Again, you can give the entire path to the file if you don't want to get into getwd and setwd. All right. Okay. So now I've been able to import this data into R, and once I've imported, now I can do the analysis of this data. Okay. So when you have to analyze the categorical data, again, it will be done in a certain way. When you have to analyze the continuous data, it will be done in a certain way, as I was saying it. So this, just to tell you, those who are not aware, this credit data is a data frame here, right? So that is one of the data structures in R. So when you work with a data frame, what really happens is it is a two-dimensional data structure. Okay, it's a two-dimensional data structure, and for this two-dimensional data structure, what it would be, and this will have multiple data types, right? It will allow you to have multiple data types. So in my case, I had both string, numeric, all those data types. So it is a data frame, right? If I want to see more about that, I can see the structure, and the structure function will help me understand this data better. Okay. Okay, if I do structure of credit risk data, now you see. Okay, guys, you can be on mute. I see a lot of disturbance at many people's end. It is better to be on mute if you have disturbance at your end, so that others at least don't get disturbed. Okay, fair enough. So here, if I look at this data, if I see the structure, this is what it says. So it is a data frame which has about 1500 observations and 12 variables, right? Now, many of them are factors. I'll talk about that again. It's difficult to explain factors at this time, but consider those are factors. This is integer. So all that integer and numeric is my numeric data. This is again numeric data. These are all categorical data which has been taken as categories. Okay, great. So I really don't have to make them categorical again, right? Now it says 1482 levels, 1482 levels, which means I think some of the data is duplicated here, right? Again, I'm not doing the cleansing of data here. Maybe I'll have another session only to teach you how data cleansing happens. And again, a difficult data, and I'll try and do the analysis cleansing that day. But today we're not really trying to clean the data. We're trying to learn statistics primarily. Okay, so this is what you have. You can understand this data, or you can click on this link also, which will run a function view data. And when you do that, see, you can see the data here in the form of a table as well. Okay. All right, now let's try and start with the analysis of this data. Now, if I look at loan ID, it says, again, if I go back and show you this, it says 1482 levels are there. Now, out of the total data that I see here, there are 1487 data points and 1482 levels, which means each person ideally should have a unique loan ID. Each person should have ideally have a unique customer ID, right? Correct. Maybe some customer has 2 or 3 loans, right? That can still be there, but loan IDs ideally should be unique, right? So if you you really would not be able to do any analysis on this data, because whenever you have every row has a individual value, that does not contribute to any kind of pattern which you can get from pertaining from this data and find any kind of relationship between this loan ID or customer ID with respect to the people charging off or not charging off, right? So it really would not make sense. It might be, you might find some kind of a pattern in there, but that primarily would be a very coincidental kind of a thing. That really would not be an statistical analysis of that data, right? So loan ID and customer ID, these are both string data, which are again of some which are again of not really a lot of use, primarily because each category, each row has a different value, and any analysis on this would not lead to anything, right? So we'll not be analyzing loan data and customer data, loan ID and customer ID, because it does not make sense to do any analysis on this data, right? Then you have loan status. Okay, let's try and take this loan status. Loan status is a, what kind of data is this? You people told me this is a categorical data, right? Now, if I want to understand what kind of categories are present, how do I draw a plot of this data and so on and so forth, I can do that, right? Now, to access any variable, right, one single variable in a data frame, how you do that is credit underscore data. So this is the data frame name. You can use dollar symbol and the name of the column, right? So if I do dollar here, okay, now it has come up, right? So once I put in tab, you'll be able to see this. Now I'm interested in loan status. So if I do this, I'll be able to get the loan status, right? All the values of loan status, only the loan status will be given to me, right? Others will not be given to me. Okay, I've cleared the console using Control plus L. The console is cleared. Now I'm again free to work with this. Now I want to do the analysis of this data, right? Now, since this is a categorical data, it'll be better if we try and find the mode of this data, right? Okay, before I talk about mode and other things. So when you have a different kind of data, when you have, say, continuous data, you can okay, there's something called measure of central tendency. Everybody understands measure of central tendency?
Yes.
Is main more than median?
Correct.
No.
Okay, hold on. So somebody does not understand. Let me explain this. So mean, median, mode is correct. So measure of
Yeah.
central tendency is primarily, suppose you have a set of data, in our case, a lot of data. If I want to take all this data and represent all this data with one value. Okay, what is that one value which can describe all this data in a best possible manner, right? That is my measure of centrality. So what is that center value where all the data is tending? Okay, that is what it means. And here it could be, as you rightly pointed out, it is mean, median, and mode. Okay, mean, median, and mode are your measure of central tendencies. Okay, now in when you have a categorical data, it does not make sense to find mean and mode, because you cannot mean and median, because you'll not be able to find mean and median of categorical data. Okay, but for a continuous data you can always find find mean and median. Even the mode can be found for a continuous data, but for a categorical data you will always be trying to find the mode. Okay, so mode will be the value. Okay, mode again, I'm not sure if, so mode is the value. Suppose you have got a lot of data points for, so that category for which the frequency is highest, which is occurring maximum number of times, that will be your mode. So mode will be the frequency with the or the value with at which the frequency is highest, that will be your mode. Okay, so mode is nothing but that category which is occurring maximum number of times. So how do I know the count of both the categories that I have here? So R allows me a very simple function, which is table function. Okay, again, as I said, you don't have to go too deep into this. A simple command would do the task for you. So when you say table of credit this, you will get an output here. So it says charged of 355 people out of 1487 here have actually run away with the money, and 1132 have actually fully paid the loan. Okay, clear. Now again, if I wanted to understand in terms of percentage, if I wanted to understand the proportion of the total data, how, what kind of analysis it is there. Suppose I'm taking this as an as say, just taking this as category. Okay, suppose this is what I've named the variable. Now if I want to understand more about this, there's a simple function prop dot table, and if I apply that on category now, again, please try and do this along with me, because I would want you to also analyze this data, right? So here it tells me that okay, about 23.9% of people have actually run away with this, and about 0.76, right? So 76.12% of the people have paid me back, right? So 24% is a pretty high default rate, right? It's a very large default rate, because the data set is small, uh, and it's taken at random, so that is why you get it like that. Okay, so this is your table function, and then prop.table function, which you can easily use. Okay, everybody who has access to the lab can easily do that. Those who don't have it can do it on their own desktop if you have RStudio. If not, you can ping me, I'll try and help you with that. All right.
So, Kushank, if I want to know that the people whose loans are charged off, so which customer IDs are those? So how can I do that?
Now you need to filter the data. Okay, so again, that will
Okay.
be I mean, I'm not going to those analysis. I can easily do a filter on this data, very simple. So I'll have to have this package called dplyr, and once I have dplyr package, it allows me to, or even I can, without dplyr also, I can simply subset this data. uh, okay, since you have asked this question, I'm answering this, but I'll not deviate much from the topic over and over again. So I'll keep you, just keep yourself to certain questions. I'll give you a chance to, get those questions solved a little later, but so that we're able to do the analysis on this data. Okay, in the meantime, others, you have done this analysis, right? I'll draw a plot also. Let's try and, okay, I'll come to your question in a while. I'm not sure who that is. So you've got this proportion. Now you want to figure out some kind of plot for this data, right? So if I try and use this function plot, and I try and say I want to plot this entire data, I'll be able to get a plot, right? Here, if you look at the plots here, Right. So this is the plot that I've got. If I zoom in here, hopefully I should be able to show you this. Yeah. So it tells me that, okay, this is the plot. Again, simple plot. Again, this is a bar chart primarily, right? Again, if I had multiple categories, I could do a plotting of that also, right? I'll do a plot of two variables, both categorical, and how do they that react, and what kind of analysis you can do. I'll do that in a while. Okay. For now, everybody, can you try and do at least this much? So when you run this table function, now you know what is the mode here. Mode in this case will be paid off, right? Fully paid, but really that does not make a lot of sense to this for now. But at least I know that, okay, out of this 76% of people have paid the loan, and 24% are the defaulters in this data set, right? Some kind of analysis I've done, some kind of an understanding of the data I have. Okay, you can simply do this much. You can do similar things on the other data set, on the other variable, maybe on you can do on term and home ownership. Can you do these two, everyone? In the meantime, I'll try and answer that question that I'm not sure who had asked that question. So that question was, if I want to know which all people have charged off in
Hi,
this.
hi Kushal. I'm myself Anubhav. I asked the question.
Okay, Anubhav, thank you so much. Uh, all right, coming back here. Um, so if you could, ask me on the chat window, at least I would know who am I talking to, right? Will help. Coming back here. So your question was, how do I filter only those people who have taken away who have taken the money and went away, right? So for that, there's something called subsetting. Okay, and what subsetting again is an important concept in R, and how exactly you do that. So I'll just show you that. So I have a certain condition. What is the condition? That my loan dot status is equals to, what is the value? You said it is charged off, right? Charged off. Okay, charged off. Now this is what I want to filter, right, from the entire data. So what you can do, uh, you can say credit underscore data. Okay, on this data I want to check whether credit underscore data dollar loan status, right? So this variable I'm trying to access, and when I'm saying comparing this with charged off, what will really happen here is that it will give me all the values where it is either it is later it is equating or not equating. You can check that up. Okay, now when you check that up, it will give you either a true or a false. Okay, it will give you either a true or a false, and based on that you can get a value, right? So now, if I again, why I have put a comma here, because I am looking at for all the rows which have this status. Okay, if I wanted all the columns, I would have put a comma somewhere else. Okay, uh, okay, now if give me one sec.
Sir, I can hear you, sir.
Okay, I'm so sorry. Now you're able to hear me, right, everyone? Okay, sorry about that. Yeah. So I was saying, everybody has done the other two, home ownership and this one, term. Anybody tried that up?
Sorry, sir, can you please show the charged off again, please?
Which one? How did I get this?
Charged. Yeah, please, just one
Okay,
sec.
okay. I'll just ping the code on the chat window. You can take that up. I don't mind that. But again, I'm saying let's focus on the analysis, the statistics part that we are trying to learn in this class. I have other sessions where I'll be talking primarily about R. Okay, so don't worry about that. Coming back here. So now when you say home ownership, have you done any analysis on this? Have you done? Created the plot? And I'm saying when you have a categorical data, there's a limited amount of analysis which can be done directly on one single categorical variable, right? When you have two categorical variables, a relationship between the two, you can do various kinds of hypothesis testing like chi-square test and understand what kind of relationship exists, whether that is significant or not and stuff. We'll try and do a bit of that. Again, I think we're already running a little short of time, but still I'll try and give you a bit of it, right? Similarly, if you have a numeric data, right? So what do you do with that numeric data? Quickly, have you done the analysis of this? At least one more variable. Are you able to do it along with me, everyone? Yes, no? Yes, thank you so much. Appreciate your feedback. All right. Now, if you have numeric data, for example, my numeric data is current loan amount, right? Now, if I have to understand this, there's a lot of things that again, I can find the measure of central tendency. I can also find another thing which is called the variability of data. Now, let me just quickly run this command, which is pretty simple command, which is summary command, which will give me a lot of this analysis. So if I say on credit underscore data, sorry, data dollar, what do I want? I want to do it on current loan amount, right? Open up, man. Current loan dot amount. Okay, when you run this here, you see again the output is there on the console. Now you see there's a minimum value, this first quartile, median, mean, third quartile, and maximum value. Okay, let me try and explain all of this to you. So mean is nothing but the average. Okay, so of all the values that I have, 1487 values, what is the average of all of that? That is 14198. That's the average. What is the median? So median is nothing but the middle value. Okay, suppose you have got, say, 100 data points, okay, or 101 data points to keep it simple. The 51st data point will be the middle point. Okay, I'm talking of 101 data points I have. Okay, if I have 101 data points, then 50 data points here, 50 data points here, and then the 51st data point, that will be the median value, that the middle value in the distribution. Again, this data has to be arranged in some order, right? Once I arrange the data in either ascending or descending order, whatever be the middle value, that's my median. Okay, now this is a odd number of data. If I had even number of data points, then this would have become 50th plus 51st data point, 50th and 51st data points. I would take these two, sum that up, 50th plus 51st, divide by 2. That will be my median, okay, for even number of data points. Okay, I'm not getting into too much, but understand that is the middle value, which is of the entire data set. If you arrange that in either ascending or descending order, where exactly you are at the middle of the distribution, that is your median. Okay, what is minimum and maximum? I understand. I hope you know. Then you have first quartile and third quartile, which is nothing but if you arrange this data again in order, first quartile is when you have taken away 25% of your data that's gone. Then another 25% you get to 50%. That is your, this is your median value. Okay, this is your median value. This is another 25% you chop off, you get to 75%, which is your Q3 here, and then the end of it, right? So either ways, if you chop 25% on either side, you get Q1 and Q3, which is first and third quartile value. Why is this important? This will help you understand the quartile or IQR, which is interquartile range. Okay. Now, what is interquartile range? I'll talk about it. So before I talk of interquartile range, what I want to tell you is, first we have already figured out the measure of central tendency. But to be able to describe a set of data, to be able to understand what kind of distribution that data follows, only measure of central tendency is not enough. You need to know the variability of the data as well. Okay, variability, how the data varies from the mean, right? From the central tendency, what is the average distance of the data? Okay, that is the variability that the data has. The higher the variability, the more will be the spread of the data. The lesser the variability, more consistent will be your data. Okay, so there are various ways to measure variability. There's something called range, which is maximum minus minimum value, maximum minus minimum value. Then you have IQR, interquartile range, which is nothing but Q3 minus Q1. You have a standard deviation, you have variance rather, and then you have, sorry, you have variance to measure it, and you have standard deviation. Okay, the various ways to measure the variability of the data, right? Range again has problems. It does not take all data into consideration. IQR is comparatively better. It takes only, chops off 25% on either side, and you get the IQR. And IQR will be helpful to find outliers in your data, right? That is where you use IQR. So anything which is Q1 minus 1.5 IQR is considered, any value which is less than this is IQR. Q3 plus 1.5 IQR, greater than this is again outliers. Okay, outlier and outlier. Okay, I'll talk about outliers, which are extreme values and stuff. But again, in the interest of time, let's get back to this. So first quartile, so where you are, so at 25% of the values have been reached when you reached 7687. 50% reached when you reached 12,000, and 19,000 when you reached, you got around 75% of the data done with. Okay. Now this will help you, draw the box plot. This will help you understand more about the data. Okay. So this summary is what it is all about. Now, when you do summary, you've got all this. Again, you can draw a plot here. Suppose you draw a plot of this variable. Okay, now the plot will come up in a while. Yep. If I see, this is a scatter plot which has come up, so I really did not want a scatter plot. If I want, I can create a histogram here. Let me create a histogram here. Okay, if I create a histogram, let's see what happens. The plot will give you a scatter plot. You can use a box plot also to create a box plot. Now here, this is what you see, right? If I zoom this, now again, I'll try and explain you a few things here. So if you look at this data is not really a normal data, right? This is not really a normal distribution. This is a positively skewed distribution. There's a skewness to the right hand side. You see the data is skewed like this. Okay. So if you look at this data here, there's a skewness here, right? There's a tail extending on the right hand side. That is why this is right skewed or positively skewed data. This you can also understand how you would understand that from the mean and median. Okay, if you look at mean and median, you'll be able to see that mean is towards the right and median is on the left side. So median on the left would mean there is a, I mean, if we can easily calculate skewness also. So there's a formula to calculate skewness. Again, I'm not getting into it for now, but understand, you can easily find the skewness of this graph, and just by looking at mean and median also, you can know what kind of skewness exists in this data. So there, the difference between median and mean is not really significant. It's not really a lot of difference. Hence, I know this is a skewed data, and since mean is greater than median, so this is a positively skewed data, and I have been able to verify that as well using the graph. Okay, again there are ways to understand the normality of data, which is a QQ plot. Maybe if I'll try and see if I have time, I'll give you that as well. Okay, so coming back here, so this is a histogram, right? Now I can easily draw a box plot also here, right? And histogram I can do a lot more variations. I'm trying to keep it pretty simple for now. Okay, if you do the box plot here, so if you draw a box plot here, you see, okay, this is how the box plot looks like, right? This box plot looks like this. There's no value which is an outlier here. All the values are lying within this range. Now, the range by default, I told you what was the range? 1.5 IQR, right? I can decide to change the range as well. I say, okay, I want the range to be, say, 1 IQR. Anything above 1 IQR is an outlier for me. Okay, so if I run this now, again, I think it is getting executed here. Just one sec. Okay, still does not show that. One sec. Sorry, not sure of the syntax. It was small box plot graphics. Yes, this is what I want. If I go to plots here, yeah, it's fine now. So it's small r. That is where I had the problem. So you see, these are outliers which have come up. Now it is taking this range to be only 1.1 IQR, and all these values are my outliers, right? Anything beyond my okay, this is basically a box and whisker plot. This is Q1, this is your Q2, this is your Q3, and this is the length of whisker. I've decided this to be 1 IQR, right? Earlier it was 1.5 IQR, so this is 1 IQR again. Anything which is beyond 1 IQR for me is outlier. Outlier means an extreme value, right? So from the median, it is too far away, and I'll not really want to take this. I want to maybe do some kind of treatment on this data before I actually do the total analysis of this data. Okay, fair enough. Again, always this time is a constraint for this. Okay, can you do quickly on another variable, on at least one variable, can you do the analysis? Okay, what does outliers tell you? So generally outliers are values which you don't want to consider in your analysis. Okay, so outliers are extreme values which you primarily consider them as exceptions in your data, right? So if you have outliers in your data, you would want to do some kind of treatment to those outliers, so that before you do the analysis, you are trying to remove the exceptions from your data. That's where outliers play a part in your analysis. Okay, Anubhav, can you do this annual income? Can you do the analysis on annual income? Everyone? Okay, a lot of people in here are really not, I mean, generally in my session, the actual sessions, I don't take more than 10, 12 people. Again, I don't think network at my end, Anubhav. I really don't take a lot of people in my batch, no more than 10 to 15 people, and there the sessions are far more interactive. I make sure everybody's, I mean, is sitting at a place where it is a little quiet for them, and then I mean, there's a lot of discussion which happens. Again, we have a lot of time also in the sessions to discuss things. There that also helps. Here in 1 hour, I need to finish everything and give you at least a good, overview of at least one data set. Becomes very, very difficult. So still, I've tried to do a bit of it. No problem. So you quickly do the analysis of this data. I'll give you one more analysis of one simple bivariate analysis of, say, of a set of data. So suppose I want to do a bivariate analysis of, again, I want to use a hash here to make it a comment. Okay, so if I want to use this, can you quickly do a simple bivariate analysis of this data? You can find the standard deviation of this data, and how would you do that? So a simple SD would help you find the analysis of this, right? Just tell you the standard deviation of this. So 8576 is the standard deviation of this data. Okay, so that tells you the variability of the data, a little more, more about the variability of the data. So bivariate is analysis between two variables. Those two variables could be categorical, continuous, and continuous, right? I'll try and do one simple, wherein I want to say do the analysis of my two variables, which is say loan status and years in current job. Let's try and do this because there are a lot of categories in this, so I'll be able to analyze that as well. So again, if I draw a simple plot here, I'm just trying to understand how this data varies with respect to each other. Okay, that's the primary motive of drawing this graph here. Underscore data, sorry, dollar quickly loan dot status current loan amount was outliers, right? So I taken such values which were outliers. So ideally, yes, as a business point of view, you would see if you have a lot of outliers, you would want to understand. You might have to treat all those data in a separate way. That's correct, right? In case of this, case of business problem that we have. So that is my. So not always you'll clean them. Sorry, somebody said something. So you would want to understand what you're really trying to do. So say loan amount is something which is in my data. I would want to maybe leave that data out. I would say, okay, if the loan amount is a very high amount that is acting in a different way, I might work that accordingly. So if I do a simple plot of this, let's see what comes out here. Okay, this is a very different. Okay, let me change this. Seems like I put it like this. Maybe this on x-axis and this on y-axis. That might give me a little better graph here. Okay, makes a little better viewing here. You see now I've got for every category, for each of this job title categories with years of experience, how the data is varying, right? So you have got okay, again, yeah. So here if you see for different categories, what is the ratio of, or what is the how many people have fully paid and how many have charged off. So I'm trying to understand if there's any relationship that I see between charged off and fully paid with all this data, right? So if I see it directly, I don't really see a lot of difference. But if I want to actually understand whether the difference is significant or not, I will have to do a chi-square test here. I'll have to apply chi-square test on this data, and then I'll be able to understand whether the difference is significant or not. Okay, so that kind of analysis will come next. Again, I don't think I have time for that. So maybe we'll kind of do more bivariate analysis maybe in some other session that I might keep. But probably you would have understood a bit more about, some of you might already know all this. Some of you might have got to have a bit more understanding of how do you work with R, which is pretty easy, and how do you actually do the analysis of data, right? So in the limited time that I had, I tried to do whatever I could. Okay, just one sec here. So I'll give you a bit more about a few other things that I want to tell you. But can in the meantime, all those who have been here, can you just fill this feedback form so that I can understand more about your requirements, your understanding of the session, what you wanted, whether you got that, was it really not achieved, or so on and so forth. At least some kind of understanding I have, so that I can I can tell you, I mean, next sessions can be planned accordingly. Okay. So that will certainly help us do that. So just put in a form. If you could quickly fill the form, that will certainly be helpful for us to improve upon that. And that's again a sincere request from everyone. And again, now I'm trying to Venkat, just fill in the form. I've given the form. It'll certainly help me. I would still want 5-7 minutes of yours, wherein I would want to tell you a bit more about what is it that we do and how we do it, so that you can know more about us. Okay, so this we primarily are into trainings of data science, right? We also do consulting projects for some organizations, and that happens purely through a lot of network that we have, right? Coming from decent enough institutes and having decent enough connections, through our network, we try and leverage that and get a few projects here and there every now and then, so that we can work through them and we can help our students also get some kind of an exposure to that. Apart from that, the course that we cover is primarily it's an online course. That's the first thing. The sessions will happen the way it happened today, a very interactive and engaging session where we really want to make you do a lot of things in the class. It's not never really teaching you a lot of theory. So for example, in here I was trying to teach you a bit of theory, but it'll be like maybe a little more into depths of this, but not really going too much into theory, and that also will be done through a lot of problems and cases, so that you are able to understand whether you are in a position to apply that or not, right? So as I said, statistics is a very important aspect of a data scientist. So we cover descriptive stats, inferential statistics, machine learning, all that in depth, right? So around 70-80 hours of our time is given to analytics, to statistics, and another 25-30 hours bare minimum we give on the tool, right? Whether it is R or Python, at least one tool we spend 25 to 30 hours to make you comfortable with that tool, and then you can explore more on the tool, right? As you move ahead, as I said, that is where your growth will come into place. Then you can we also do teach Tableau in the course, because that is required as a data scientist to be able to visualize the data. You need to understand how Tableau works, and we'll be making you do a lot of dashboarding in Tableau, understanding integration of R with Tableau, with Python, how it works, how do you take all that data and do the analysis. So we'll be doing all that in the course. SQL, again, for people who are new to this, who have never done SQL, around 15 hours we spend on SQL, which is again more of a complementary module, and that is where it is. Once you're done with this, about 130 to 140 hours of training, which will cover a lot of those things. And again, we try and strive to go into depths of thing, and that is why we take a lot of time doing it, right? I could easily complete all of this in 70 hours, or people do it in 50 hours also, but I'll talk about that. uh, uh, now okay, so I can do it in 50-70 hours also, but we really strive to make sure that learning is complete, right? You go back as a confident individual who can take up a machine learning case and start doing analysis of that, right? Bhanu will come to those questions. Give me one minute. So machine learning, especially, that is where the crux lies. So for every machine learning case study, you'll be spending every machine learning algorithm, you'll be doing about 2 to 3 case studies in the classroom, right? What you go back do at home is a different matter. You do at least a couple of them in the classroom, so you learned so many things during the class itself. Once you're done with this entire 130 hours, 140 hours of training, then you work on real-time projects, which will be taken from Kaggle, Crowd Analytics, and some other, big data sets which we'll have, and we'll give you those cases to work on, right? What that will do is, whatever you have learned, you try and implement that. So one case will go on simultaneously with the course. You'll take one case, maybe credit risk modeling itself, and you'll do that case along with the course. You try and implement a lot of things throughout the course. But later on, you try and take at least four or five different cases, and take one case at a time, solve it, and then we'll be discussing that case in the classroom for about 4 or 5 hours. Next case you take about a couple of weeks, work on that case, come back, struggle on that, you'll fail, you learn, and then again discuss and know more about that. Like this, when you do 4 or 5 cases, you'll improve upon how exactly data science works. Okay, since this happens online, it happens at certain times, which is either 7 to 9 in the morning on weekdays. Okay, 7 to 9 in the morning on weekdays, and that is Monday to Friday. So Monday to Friday, 7 a.m. to 9 a.m. in the morning, which is about 10 hours per week. So thereby you do about 3 months. You do about, sorry, you do it about for 3 months, and then Saturday and Sunday you do it for either 10 to 2 or 3 to 7. These are generally the batch timings. So you do about 8 hours per week, thereby you extend it for about 4 months. That's the time frame we look at to cover everything. Okay, and then you, once you're done with this, then you go on and do the projects. So not counting this project time over here. Okay, all right. And then once you're done with all of this, then you and since this is online session which is happening at certain times, all the sessions are recorded. Recordings of the sessions are provided to you. You are already accessing the lab. You'll have access to lab. Again, individual access is created for everyone, where you have Python, you have Tableau public in there, you have R in there, so you can easily work with any of those tools, right? um, SQL is there. Now, again, batch size is limited. We really don't take a lot of people. We encourage a lot of hands-on. We encourage you to speak also in the class, because provided everyone is up and running and really interested therein, I allow you to speak a lot. Here it becomes a touch difficult with more participants, and not everybody is really sincere with background noise and stuff. Others do get disturbed, so I try and avoid that. Um, Here, then there'll be, as I said, recordings will be available to you online all through your time. And whenever you miss a session, right, the live sessions, all the sessions are instructor-led live sessions, right, the way it is happening now. So you will be able to, if you miss a session, you do it again in some other batch, right? You'll have the recordings, plus you again come back and do it in another batch live, right? So that you can get the full value of this. Later on, it'll be placement assistance, project, and other stuff, which will obviously come into picture, right? So this is your LMS where you'll have access to things, and this, you're already accessing the lab. And this is bit about you can know a bit more about us. Okay, there's one question which is coming up: what is the cost of this fees? So the cost of this fee is about uh, yeah. So okay, so there are a lot of books you can use. You can use ISLR for ML, which is a very good book. For R, you can easily use Art of R Programming. That is again a very simple. When you start, right? Again, as you move further, you can learn more about it. So the cost of this course is 30,000 rupees from 1st of December. But if you kind of lock your seats for the next batch, even by 5th of December, the fee still, O'Reilly books are really good, correct? Uh, so if you try and lock yourself for the next batch, the fee still would remain 25K. So 25K will be fees if you lock it before for the next batch before 5th of December. Yeah, 5th of December, and post that the fee is going to become 30K. Okay, so you'll have that opportunity. I might be sending out a mailer. The team, somebody will be sending out a mailer to you as well on that, and you'll have an opportunity there as well. Okay, but understand it is to crack a data science role, it will be yeah, I'll talk about. So we don't charge you everything on day one. We charge you only $5,000, and that's primarily because we want to give you enough exposure to understand whether you're somebody who likes data science or not. To what extent do you really like our methodology? Because 1 hour can be a deception, right? 20 hours will not really be a deception. So uh, we will try and we try and help you with that as well. So it's more important for us to give you a lot of value, to give you a lot of a lot of insights, and when you go out after the course, you should be industry ready. For us, that is very, very important, because at the end of the day, if you're able to go out there and solve problems on data, you certainly will be able to add more to your career, more to your profile, and that is what is the ultimate aim. Anubhav, certainly you can add me on LinkedIn. I'll do that. So my complete name is Kushagra Singhania, and you can always connect to me on LinkedIn. I might not have seen that, so uh, so that is where I might have. I mean, if you've pinged it now, I really don't know. If you've pinged it earlier, I might not have seen that. Okay, no problems. You can do that on LinkedIn. I'll generally connect with most of the people. Uh, that's perfectly all right, Anubhav. So those who are working with analytics, those who understand analytics, again, it's important to dig deeper into data, to have passion for problem solving, and that is where you can grow as a data scientist, right? And for everyone, right? So that is something which is very, very important. I've seen a lot of people, just because everybody is saying that data science is the thing to go, they're trying to come in and spend some money, some time, and really backing off after good 1-2 months, which not really is the best thing. So you try and understand yourself a bit more, and then jump the gun. But when you get in there, get in with full passion, get to people who really are passionate about training you, giving you a lot of value. For us, again, that is something very, very important. Okay. All right. If you have, I'm assuming some of you have filled the forms at least. If not, I would again request you to please fill the feedback form, which is present in this link. It really would be a great help for us to improve further. So again, a sincere request from everyone to please fill the form, and I would appreciate your feedback. All right. Now I'm opening the floor for any questions that you might have. Again, I forgot to do that. Quickly, I'm opening the floor for any questions you have. I am open to answering that now. Anybody, any questions? Okay, I think it's all about, sure, Anubhav, thank you so much.
Kushagra, one thing I would like to ask.
Go on.
Do you include Rattle also in R, or this kind of programming only you do?
No, so I mean, see, a lot of people in the sessions are still pretty new to R, right? So therein it lies the difficulty to do an advanced R session. So we can do advanced R session for a few individuals who are interested, but in the course we really don't include that. Okay, so we primarily do it with RStudio only, and trying to do basic analysis first and then ML on that data, which still, the foundations is something which we are more focused on. And again, there are the other things that, as you say, are done in other courses. So we have another course for big data analytics. We have another course for NLP. So therein you can do more on R, more on other things. Once you're confident about the tool, once you're confident about at least basic and intermediate machine learning.
Okay.
Okay.
So you particularly you start with the initial things like what do you say, predictive variables and taking sampling and all. You start with that.
Yeah, so we'll try and give you enough, enough.
Variables.
Okay, sorry. There's another question. Okay, sorry. Your question was, what do we really do? So in our course, we try and cover everything from the very basic level, be it statistics, be it R, or be it So again, in the course, I'll teach you from the level of what is a lurking variable, why do you do sampling, how exactly it is done. But I'll not spend hours in there. So maybe 1 hour I'll try and give you a bit of theory, because that's more of a theoretical topic. I try and do a lot of questions and problems, and through that I try and explain the concepts. So therein theory part will still be limited. You do more and more problems in there. That's one thing. But starting from the very scratch for everyone, considering you know nothing, right? For me, you're a novice. You might be an expert in ML also, but if you're doing the course, you can do an advanced course, which again there's another way for. But this course, the one that I'm talking about now, that is from the scratch. Okay. Next question Chavi has. This course will be beneficial for you, Chavi, if you have good knowledge of statistics. There also, you can if you know basic and inferential statistics, you can still do ML and R and advanced ML, and then the other course that I talked about, the Tableau and SQL. I don't know what exactly is your background and to what extent you know things, because when you say you have good knowledge, that good is very subjective, right? For various individuals, that good can have very different definitions. So that is something which I have to talk to you on personally and understand what you know, and then I can suggest how much you need to learn further, and what all do you need to learn further, and accordingly I can say whether this course is better, you can take the advanced course, or how you should go about it. So machine learning is one step further, where you're creating equations, understanding when that's modeling multiple variables. It's primarily machine learning is about modeling the data, understanding more about the data, right? So this is basic simple analysis. You start with this, go on and do the machine learning a little different way. You can do the machine learning session again, and you'll be able to understand a little more about that in the session. Okay, how much time will be spent on machine learning? In this course, we spend about 50 hours on machine learning alone, at least 50 hours, right? So as I said, we do about 12 to 13 algorithms, and
Sure.
post that, and every algorithm you do at least a couple of cases, and post the course again, everything is machine learning, right? You take a case and you do entire machine learning on that. So another 15-20 hours you can very easily add to that. So there'll be a lot of ML which will be taught in the course, because that is the crux for being a data scientist. Okay, any other question anybody has? So Chavi, somebody might give you a call and understand your requirements, and then they might help you more. So from the team they might give you a call. Yeah, we'll be working on Kaggle datasets as well. We'll give you Kaggle datasets and make you solve those. And again, some of them are very complex, some of them easy to understand, medium level. So we'll give you difficulty levels, and so that you don't really feel out of the place on any given day. You slowly and gradually get to a level where you're confident about things, you're able to actually do the analysis. All right, any other question, anyone? Last 1 minute, please. Okay, fair enough. Seems like we are good. So I really appreciate you all being here in the session. Probably you took out time on a Saturday evening, especially, right? So appreciate that, and thank you all for being here. And I'm not sure how much value I was able to add to some of you, but really tried to do as much as I could. So in the limited time that we had. So really again, thank you all for being here, and hopefully we'll connect back again for further sessions. All right. So thank you so much, guys. Logging off now. Bye bye. Good night.